This not-to-scale illustration represents a peak new moon during a perfect solar eclipse, meaning the moon is perfectly centered on the ecliptic plane. The angle from the terminator line to the sun is 2/1000ths of a degree. We'll call it 0 for now. The angle from the terminator line to the moon is 98/100ths of a degree. Let's call it 1 degree. So there is effectively a 1 degree discrepancy between viewing the sun and a perfectly eclipsed moon from the terminator line. This 1 degree angle is identical for a peak full moon during a perfect lunar eclipse, where the moon is perfectly centered on the ecliptic plane. The first premise of my argument is that a person on the terminator line cannot see the peak new or peak full moon when they are in the perfect eclipse position I described earlier. This is because in the heliocentric model, the sun is 400 times farther away than the moon, causing that 1 degree of discrepancy. Nobody denies this. The globe proponents do, however, claim that refraction lifts the sun and moon half a degree higher in the sky at the horizon than they actually are. So let's do that with the sun first. At this point, the upper limb of the sun is just visible above the horizon for a person on the terminator line here. We're going to leave that sun right where it's at and freeze the Earth where it is for this demonstration, because we're only interested in what a person on that terminator line at a precise moment in time can see or not see regarding the moon. So from here on out, the sun and moon are locked in position and will only be moving the moon as needed. Now keep in mind that this sun remains a little above the horizon for our guy on the terminator line, whether the moon is at peak new, waxing crescent, peak full, or doesn't even exist at all. But we're going to start with it at peak new and give it the half a degree of refraction that the globe model requires. And let's face it, the refraction is definitely required to give that model an air of validity. So now we've refracted the sun by half a degree and the moon by half a degree. But that original 1 degree of discrepancy between the two remains the same, since we've moved them both the same amount. Keep in mind that this is not to scale, and so it's not going to look exactly right. Here I'm showing that 1 degree discrepancy from upper limb to upper limb, from the perspective of our terminator guy, of course. But I could make it center to center, or lower limb to lower limb, and the 1 degree remains the same. So geometrically, there is a 1 degree angle from our terminator guy to this perfect eclipse moon in its actual position. But refraction lifts the moon half of a degree. So what is his angle to the refracted moon? Right, half a degree. So can our observer see that refracted moon peeking over his horizon with the sun? Absolutely not. Even with their unsubstantiated and easily refuted half a degree of refraction, the moon still needs to be an hour or two away from peak new position before our guy can see it on his horizon. And the globe proponents agree with this. Of course, they have no choice when centuries of solar eclipse observations make it clear that sunrise terminator guy sees the eclipse when the moon is here. Then a while later, the Middle Earth people see the eclipse at high noon when the moon is in peak new position. And still a while later, sunset terminator guy will see the eclipse when the moon is here. So how then can NASA say that refraction alone is enough for that same terminator guy to see a Salanelian lunar eclipse? Ruhiff and Harry think they got it figured out. They point out that the effect of refraction is doubled for lunar eclipses, since both sun and moon are refracting towards the terminator guy. That actually makes sense at first glance, like clock hands on the 3 and 9, and moving them both down towards the 6 is closing the 180-degree gap that was between them. But consider this. The actual position of the peak moon during both solar and lunar eclipses is in a perfectly straight line in space with the sun and the Earth, right? And at this precise moment in time, our terminator guy is seeing this refracted sun peeking over his horizon, regardless of where the moon happens to be, or even if there is a moon, right? So if the moon is at peak new, terminator guy's angle to its actual position is 1 degree, right? And if the moon is at peak full, his angle to it is also the same 1 degree, right? And if we refract the new moon half a degree, his angle to its refracted position is half a degree, right? So what's his angle to the full moon if we refract it by half a degree? Yep, the same half a degree. So while I definitely understand their point, hopefully you and they can understand mine as well. And keep in mind that this double refraction argument and their entire model only works if the sun and moon truly do refract upwards a half a degree on the horizon. But for now, let's allow the double refraction, and even allow that it would be just enough to get that peak full moon to peek its head over the horizon along with the sun. It's still not enough to help them with Ron Hagberg's observation, because if you remember, although Ron wasn't able to film the moon all the way to the horizon, timeanddate.com tells us that the moon set in his location at 6:34 a.m. and peak full wasn't until 7:26 a.m. Which magic hat are they going to pull that extra 52 minutes out of? They tried. A lot of them mentioned that Ron's footage spanned a lot of time, and in their model that means Ron was rotating along with the Earth towards sunrise. Okay, but we are only interested in the precise moment when both sun and moon were peeking up over Ron's horizon, so that argument is irrelevant. And in case you missed it, that happened in Ron's location 52 minutes before the moon even made it to the peak full position. Jerry thought the difference in solar and lunar eclipse shadows could solve the problem. But while the shadows are great observational evidence for showing us what's going on with the sun and moon in real time, we're actually only interested in the position of the moon itself and the point at which somebody on the terminator line could see it on their horizon. And since that is the case, it doesn't matter how big or pointy you imagine the shadows to be, because it truly has no bearing on my argument. Wolfgang believes some help may be found in Ron's location at 30 degrees north latitude. But anyone on the terminator line, anywhere on Earth, at any time, has the same angle of view to the sun. It doesn't matter if the person is at the North Pole, on the equator, somewhere in China, or in Chipley, Florida, 30 degrees north of the equator. If you are on the terminator line, you have the same angle to the sun as anyone else on the terminator line. That holds true for the moon when it's peak new or peak full, and aligned on the ecliptic plane, as in a perfect solar or lunar eclipse. So had the moon been at peak when it set in Chipley, Florida, then Ron would have had the same angle of view to it as anyone else on the terminator line at that time. And as we know, Ron's moon wasn't at peak full when it set. It was another half a degree on the far side of peak full, making it almost an entire moon diameter farther beyond his view than it would have been at peak full. So even allowing for your half a degree of refraction and allowing another half a degree for Harry and Ruhiff's double refraction claim, the moon was still another half a degree, or 52 minutes of moon orbit, away from Ron being able to see it on his horizon with the sun. And you guys have no explanation for that extra 52 minutes. None whatsoever. In fact, if we weren't erring on the side of the globe and allowing for your completely unsubstantiated refraction claims, it would be 3 hours of moon orbit that you'd have to account for. And Ron's observation is certainly not unique. YouTube has a lot of selenelian observations, including this one where the sun and eclipsed moon were on the observer's horizon a whopping 89 minutes before peak full moon. That's 37 more minutes on the far side of peak than Ron's moon was. And if you can't even account for Ron's 52 minutes after we've allowed you an entire degree of double refraction, how in the heck will you account for 89 minutes? And where does it end? How about we end it right now by eliminating your refraction rescue device using testable, repeatable, observational scientific evidence? Do you guys remember this footage from previous videos? The sun and moon peaked over this observer's horizon 2 hours and 6 minutes before peak new. And if it weren't for that pesky refraction claim of yours, this observation actually fits your model. But once we add your half a degree of refraction into it, it destroys your model. How ironic that the thing saving your model is the thing killing it, huh? Let me show you. This is the wiki page on that eclipse. You can see that it took about 4 hours from total begin to total end, with peak nu in the middle of that duration. That fits the heliocentric model, which says the moon's diameter is a quarter the size of the Earth's, and that the moon orbits at a speed of 1 moon diameter per hour. So basically 4 hours for the moon to orbit across the face of the Earth, right? So at the beginning of totality, the moon was just coming between the Earth and the sun, and our observer shot that previous video of the eclipse sun rising from here. After an hour of orbit, the moon would be between the sun and here, and people here would be in the shadow and see the eclipsed sun in their sky. An hour of orbit later, and the moon would be at peak nu, and people in this location would see this eclipsed sun at high noon. By the end of hour 3, the moon has orbited to between the sun and here, where these people can now see the eclipsed sun. And by the end of hour 4, Terminator guy here can see the eclipsed sun set as it orbits to where it is no longer between the Earth and the sun. So a moon the quarter the diameter of the Earth orbiting past the face of the Earth in about 4 hours fits the heliocentric model nicely, until we add in that half a degree of refraction. Because when we add in an entire moon diameter of refraction, then we must accept that our observer in Western Australia was filming a refracted moon here. And then we have no choice but to say that the moon's actual position at that moment was here, right? And that means that while our Australian observer was seeing an eclipsed sun rise, someone else 3,000 miles away was seeing an eclipsed sun up in their sky. So you globe proponents have a decision to make. Either reject your completely fabricated idea that the sun and moon appear a half a degree higher in the sky on the horizon than they are in reality, or claim that people 3,000 miles removed can experience an eclipsed sun at the same time. So what's it going to be, fellas? Either Terminator guy is seeing the moon in its actual position eclipsing the rising sun, or he's seeing the moon in its refracted position, leaving no other option but that somebody else, thousands of miles away, is seeing the actual moon eclipsing the sun at the same time. Oh, and the half a degree of lift due to refraction also means that while sunset Terminator guy sees the moon in its refracted position eclipsing the setting sun, another observer, again about 3,000 miles away, is watching the actual moon eclipsing the sun in his sky, right? And if this were the case, the entire time between sunrise Terminator guy seeing the eclipsed sun rise and sunset Terminator guy seeing the eclipsed sun set would only be 2 hours, the time it would take for the actual moon to orbit from here to here. Shall I keep going? Okay. What exactly do you suppose Terminator guy sees when the actual moon is actually just beginning to come between the Earth and the sun? I mean, is he seeing a refracted moon up in his sky while the actual moon is casting a real shadow on him? It seems to me that you guys are between a rock and a hard place. You need that refraction to explain Selenelian observations, but solar eclipse observations refute it. And they're not the only thing that refutes it, but this video is already long enough, so I'll hold off on the other stuff for now and see what buts you have to offer to what I've presented so far. Thanks for watching, and a special thanks to Mr. Thrive and Survive, Taboo Conspiracy, Antonio Subarats, and Seventh Day Truth Seeker for bringing many more eyes to my work in exposing globe Earth deceptions. It's much appreciated, fellas.